Okay, we've got our program, so it will draw George on the screen. Now let's try a few other things and see what we can do with this picture. First of all, I want to show you a common mistake, and that would be forgetting to initialize your rectangle. So I'm going to go up here, and this button here will let you comment out a bunch of lines at once. You don't have to go and type / at the beginning of everything. So if I forget to initialize it, that's not an error as far as the language is concerned. It will, if you don't initialize variables, it will put a value in there for you. The value it puts in for numeric variables is always 0. So my rectangle is going to start in the upper left-hand corner, but it's going to have a width of 0 and a height of 0. So if it's 0 pixels wide and 0 pixels tall, it's awfully hard to see. So let's run this program, and even though we've done everything else right, we've declared our texture, we've loaded the texture, we've got the draw command in there, when it comes up, all we're going to see is blue. And you can, look as hard as you want to, and you're not going to see anything up here because 0 pixels by 0 pixels is basically nothing. It's invisible. Okay. Now, so if I do uncomment these two, this is the uncomment button up here, and run the program again. Even though I did initialize X and Y, their default values are 0. But in general, it's probably not a good idea to rely on default values. I think it's better if you explicitly initialize variables. There may be some languages that do not use the same default values that you're expecting, and so it's just a better idea to explicitly initialize all of your variables. And there we go. So even though I didn't initialize them, they still have the value 0. We're still going to get the same results. So let's stop that program. And like I said, I like to explicitly do this, so let's uncomment that. Okay. Now, once you got George on the screen, what can you do with him? Well, any changes you're going to make are going to be in update. And so some of the things that we're going to want to do in update, let's change the size of George a little bit. So if I want to change the size of the picture on the screen, I've got to change the size of the rectangle that the picture is drawn in. So George rectangle dot height ++, and George rectangle dot width ++, and that red wavy line should go away, and it does. And now let's try to run it. And every 60th of a second, it's going to grow by 1 pixel. So in 1 second, it should grow by 60 pixels. And since I start off at 100, and my screen is 480. In about, what's 380 divided by 60? In about 6 seconds, it will hit the bottom of the screen and start overflowing the screen. 2, 3, 4, 5, 6. And eventually, he's just going to keep on growing and growing and growing, and eventually all we're going to see is just a little blob of brown up here in the upper left-hand corner because we didn't put anything in to tell it to stop. But we'll stop the program right here. And so that's one way you can manipulate an image on the fly. Now I don't want that in the next thing that I do, so I'm going to comment that out. So what else can you do when you've got an image on the screen? Well, you can make it move across the screen. So you make it move by changing the X or Y coordinates. And I'm just going to change the X coordinate here and add 1 onto it. And so every second it'll move 60 pixels. And if I wanted to move 800 pixels across the screen, that's going to be about 14 seconds or so. And what happens when he gets to the right edge of the screen is we keep on updating those coordinates, and he keeps moving and moving and moving and moving and moving, but since he's off of the visible display area, we can't see him. So that'll just keep on going forever or until we stop the program. And if I want to make him move in, let's comment this out. If I want to make him move in the vertical direction, whoops, add on to Y, and this should get him to move straight down the screen. And there he goes. And again, he's going to disappear off the bottom and we'll never see him again. And if I move in both directions at the same time, George will move at a 45-degree angle down and to the right until he disappears off the bottom of the screen, because he's going to get to the bottom before he gets to the right edge. And there he goes. Okay, now let's try a few other things here that we can do to manipulate the image. If he's just moving in the X direction, he's going to eventually go off the right edge of the screen. And what I want to do is I want to make him reappear on the left. So I need to check. I'll know that he's gone off the screen. The last coordinate that is on the screen is 799. The pixels are numbered from 0 to 799. And so once it gets past 799, he's off the screen. So I want to check to see if George rectangle.x is greater than or equal to 800. And if it is, then I'm going to reset it to 0, which will make him reappear on the left side of the screen. So let's run this program. And we're going to have to wait 14 seconds here. But when George disappears off the right side, he will reappear on the left side. And he'll continue to do that over and over and over and over again. Okay, there he is. And it's just going to keep on looping forever or until we stop the program. Okay. Now, let's try doing the same thing in the Y direction. I'm going to comment these out. And if you think you might want the instructions later on, comment them out, don't delete them. And in the Y direction, I want to see if he's gone off the bottom. And he's gone off the bottom if the Y is greater than or equal to 480. We want to set it equal to 0, so he goes back to the top of the screen and starts over again. And let's run it. And when he gets to the bottom, he's going to reappear on the top. And there he is. And that'll keep going forever until we stop the program. Okay. And if we uncomment this and do both of them now, he's going to move over and down. And when he gets to the bottom, he's going to reappear on the top. But the x-coordinate hasn't changed, so he's going to appear right up here near the top somewhere, and then he's going to disappear over here on the right, and then he's going to reappear over here on the left at the same spot, and drop down. And we're just going to keep him moving at a 45-degree angle, and every time he goes off the bottom, he's going to reappear on the top. Every time he goes off the right, he's going to reappear on the left. Okay. Now, I have built the number 800 and 480 into my program here, and in general, it's not a good idea to build constants into your program. It's okay to build a constant 0 in like we've done here, or build a constant 1 in. You know, here I'm doing a +1 basically. But numbers other than that, any number that could possibly change at some time in the future, and if your screen size could change, then these should probably not be constants, numeric constants built into your program down here in Update. So what you should do is you should probably initialize a couple of variables up here, and there's more than one way to do this, but we'll look at the simplest way right now. And you know what, I want to make these constants. I'm going to do them in caps like we do in most C-like languages. And let me go back and redo this one. And I said I was going to make those constants. I didn't put the word constant on the front here, so that should make give me a couple of constants. And then what I want to do down here is I just want to make that screen width and screen height, and there's no need for me to type that. And now the program will run exactly the same. Okay, so there's really no change in the way the program works, except your program is now a little bit more readable because you don't have a magic number 800 in there that somebody has to try and figure out what it means. They see screen width and they know exactly what it means. Okay, so you can initialize those variables. There's two places to initialize. You can initialize a lot of variables when you declare them if you want to, or you can initialize them here in the Initialize method. Either one works. And now I want to try one other thing. I'm going to comment out the George, the Y stuff, and we're going to increase this. Instead of adding 1 onto it, we're going to do plus equals 2. That means just add 2 onto it and then put the value back in here. So he's going to go across the screen twice as fast. If it took 14 seconds before, it's going to take him about 7 seconds to move across the screen now. And when he gets across the screen, he's going to reappear. Okay. Now, what you might do when you're checking to see if something is gone off the screen is you might check to see if it's equal to 800. Okay, so you might have written your program like this the first time instead of greater than or equal to, and this will work just fine. If I run the program again, eventually it's going to get up to 800 if I add 2 on every time, and when it's equal to 800, it'll disappear off the right side and it'll reappear on the left side, as we'll see here in a second. Yep, and it reappears. Okay, now I'm going to change this to a 3, and I'm going to run the program. And when George disappears off the right side of the screen this time, something interesting happens. And the interesting that happens is he never comes back. And the reason he never comes back is because if you add 3 onto X over and over and over again, you skip over 800. You will get to, let me see, 795 is divisible by 3. Add 3 onto that, you get 798. Add 3 onto that, you get 801. And so if you're checking to see if it's equal to that position that's 1 pixel off the screen, it's not always going to work. You could jump right over that. So the smart way to see if something has gone off the screen is always check to see if it's greater than or equal the screen width. And if I do this now and run the program, 801 is greater than or equal to 800. So when I do finally get off the screen, this time he's going to reappear back on the left side again, and that'll work forever. And now it doesn't matter what we choose for an increment value here. Eventually we will get to a point that's greater than or equal to screen width, and then we will go back to 0 and start again. And let's stop the video there, and we'll continue with some more stuff in another video.